Hello guys, how are you? Welcome back. We are continuing with our topic, general properties of waves. Re tla simolola ka gone go leba wave equation. So wave equation is V is equal to F times lambda, where V is the speed of the wave in meters per second. And then the frequency is denoted by F and the units are hertz. Berenale lambda, which is the wavelength in meters. Again, me go sa re go ra o hilwe ni centimeters ka se dirisa again. Yaanong the example e kitse first question number 1. The wave has a speed of 300 meters. 3000 meters per second, 3000 meters per second. What is its wavelength? If the frequency is 2 kilohertz. So what is the wavelength of this wave if its frequency is 2 kilohertz? So what is it we have? All right, my data. So ke kwala di-value tse ke di hilweng mo ke speed in V 3000 in what meters per second, right? Then re na le frequency ga te ke 2 kilohertz. Me right, so kilo means what? 1000. Okay, so this is equal to 2 times 1000 hertz, which is 2000 hertz. I get rather get 2000. So rabatai wavelength lambda question mark. So formula yari V is equal to F times F. So harnally 3000 is equal to F again get 2000 lambda. So what do? We divide like 2000 both sides. 2000 cancels 2000. And the other side we divide by 2000 as well. Both zero are cancel. Then 3 divided by 2, this will be equal to 22. 1 into 3, 1.5. 1.5 is equal to lambda, and this has to be in meters. Therefore the wavelength lambda is equal to 1.5 meters. So this is our answer. Question number 2. A wave has a period of 0.001 second and cover a distance of 900 meters in 2 seconds. A, calculate the speed of the wave. B, determine the frequency of the wave. C, what is the wavelength of the wave? First things first, A, requiring data period T is equal to 0.001 seconds, right? Distance, S for distance is equal to 900 meters. Then we have T, which is 2 seconds. We are to find V. V is question mark. We are to find V. So we have two formulas that we can use here. The wave equation, which is V is equal to frequency times wavelength, but we don't have frequency, we don't have wavelength. So we cannot use this equation to find v, but we have distance and time. Every time you have distance and time, you can always calculate the what? The speed. Therefore, speed is equal to distance over time, which is 900 divided by 2, because 900 is distance s and t is 2. This is v is equal to 450 units meters per second. Meters per second. So that's A. How about B? B, determine the frequency. Determine the what? The frequency. Frequency is equal to 1 over t. And remember, t is 1 over f, right? So in this case, we are looking for frequency. That will be 1 over 0.001. 0.001 seconds, right? So this is 1000 per second. So this is 1000 hertz. So this is the what? This is the answer to B. So C, we are to determine the wavelength. Let's find the wavelength. So let's use this space here. C, the wavelength, question mark. Well, the equation that has a wavelength is the wave equation. Only wave equation has a quantity wavelength. So that means we have to use this equation. And we are glad we have the speed. The speed is here. The frequency has also been calculated, is here, right? Therefore, V is equal to F times lambda. V is 450. Frequency is 1000 times lambda. What do? Divide both sides by 1000. Dividing both sides by 1000, we'll have these cancel out. 1000 into 450 is 0.45. That's 0.45. Therefore, lambda wavelength is equal to 0.45. The units, the speed was in, because the units for length, meters, so it has to be meters. But if you had included them in your calculations, the meters will come out as it's supposed to be. So this is the answer to C. Okay, so that's it about the wave equation. Let's end here for this lesson. Thank you.